Properties of cross correlation. We know that cross correlation means it is the relation between two different signals denoted with R, X, Y of tau is equal average of two different signal. I am assuming X of t is one signal and Y of t plus tau is one more random variable. If X of t comma Y of t are two random variables, random process. So here just example I am assuming. So this is the random process X of t in 2025, and I am assuming this is another random process Y of t plus tau. It is in 2026. So what is an average? Average. It is having 2 volts and it is having 3 volts. What is an average? 2 plus 3 by 2. Just assumption only. 5 by 2 is equal to 2.5 is an average. So the cross correlation means the relation between two different signal with different time slots is called, that is the cross correlation. I will explain the properties, main properties. Property 1, I am explain property 1. So Rxy of minus tau is equal and Rxy of tau. So coming to the proof, as we know that the cross correlation Rxy of tau is equal E of x of t multiplied, that is y of t plus tau, y of t plus tau. This is so, but we want Rxy of minus tau. Let tau equal minus tau. Substitute in both sides, then we can write it as Rxy of minus tau is equal E of x of t into y of t minus tau, y of t minus tau. So here again we can assume that let t is assuming the let t minus tau is equal to u. T is equal to u plus tau. So for simplification we can assume this one and substitute here. Now we can write it as E of x of t means x of t is equal to u plus tau, we are assumed, and y of t minus tau means that is y of u. So this is in the form of average of two signals, that is Rxy of tau. This is equal Rxy of minus tau. This is the property for cross correlation. One more property I will explain. So important property, that is property 2 is if x of t comma y of t are independent, y of t are independent, then random process are independent, then I can write it as E of cross correlation Rxy of tau is equal, we can write it as E of x of t multiplied with, we can separate E of y of t, E of y of t. Coming to the proof, we know that already the cross correlation function Rxy of tau is equal average of two signals. We know that, that is x of t into y of t plus tau, t plus tau. So now we need the separation. That's why I'm assuming this is if it is cross correlation, sorry, if it is stationary, so we can write it as if it is stationary, if it is stationary, you can write it as y of t is equal y of t plus tau. So therefore we can write it as v of x of t into y of t plus tau equal to y of t. So we can separate expectation average or else E of x of t multiplied with E of y of t. E of y of t. This is R x y of tau. This is the property 2. And coming to the property, if x of t and y of t, the means are equal, we can write it as, by using this only, we can write it as property 3. Property 3 I'll write here. So if means are equal 0, then we can write it as Rxy of tau equal to 0. Mean means E of x of t. If it is 0, we can write it as 0 into 0, that is equal Rxy of tau. So this is the third property. Third property. So as I said, these are the important properties for cross correlation. As I said, if two random process x of t and y of t plus tau, the relation between two random process is called, that is cross correlation, or else average of two random process is called, that is cross correlation. Thank you. If you have a doubt, you can send to me.